All right, this is the Matrices test review video. Follow along. There'll be some problems that I'll probably just show the answer really briefly. Particular problems like 3 and 4, I probably won't do the work and I'll just show the answer, but others I will go through. All right, so starting with number 1, gives us matrix A. It wants us to find what is 3 over 2 times matrix A plus matrix A. So I've got the setup right here. I have inserted matrix A here and here in the equation, and it's just a matter of first multiplying everything in this first matrix by 3. So when you multiply by a fraction, you multiply everything in there by 3 first, and then after you multiply everything in there by 3, then we're going to divide everything in there by 2. So that's what I get when I multiply everything by 3. Now I've got to take care of this 2 on the bottom of the fraction. I'm going to divide everything in here by 2. You can pause if you need to. If you need to copy down the work, just slow it down and make sure you're understanding it. So that's what I get when I divide everything by 2. So now I've multiplied matrix A by the fraction 3 over 2. I did it in a couple of steps. But that's probably the way a lot of you want to go when multiplying everything by a fraction. Then our last step is now we need to add the A, the second A in that problem we need to add it. So we're just adding 6, 15, negative 9, 0, negative 3, 12 to the original matrix. And whatever we get there is our final answer for number 1. So number 1 is complete. It is the matrix 10, 25, negative 15, 0, negative 5, 20. 2 by 3 matrix. That's our answer. So I'm going to go ahead and erase, so make sure you got it copied or you need to pause right now. So number 2 is basically like number 1, with actually a little bit less work. All we're doing on number 2 is scalar multiplication. So we're multiplying everything in the matrix by the fraction negative 4 over 3. So again, we probably want to do this in 2 steps. I'm going to first multiply everything by negative 4. That's going to be my first step. And then after I multiply everything by 4, I'm going to divide everything by a positive 3. It doesn't matter which number is negative. You could have also multiplied by a positive 4, but then you would have divided by negative 3. One needs to be negative, one needs to be positive. So I'll multiply everything by negative 4, and that's what I get. Double check your work, double check mine. And now my second step is I'm going to divide everything in there by positive 3. Remember, the test is multiple choice, so that should help out a little bit with if you make one tiny arithmetic error in the problem and the rest, everything else is right. You should be able to distinguish which is the correct answer. All right, so here's the answer to number 2. 20 over 3, I just left it as a fraction. If you use the decimal, that is fine. But if you get a crazy decimal like you do for 20 divided by 3, it just makes sense to leave it as a fraction. But that's our answer to number 2. So I'm going to skip through 3 and 4. I'll give you the answers here in just a second. All right, so there's 3 and 4. 3 should be an easy problem. You're just adding numbers that are in corresponding positions. Don't overthink that. Make sure you pay attention to the sign. If you're not multiplying, you don't have to worry about rows times columns. Number 4, make sure you can do this one. The subtraction problems, the process is pretty simple and straightforward. It's easy to make a minor arithmetic error. So double check, make sure you can do 4 on your own. But you want to go ahead and pause if you're still copying these answers. I'm going to erase and move on. So starting with 5, here we're multiplying 2 matrices. Of course, the first thing we want to do with multiplication is make sure it is possible to multiply. Both of these matrices have 2 rows and 2 columns. So this one's pretty straightforward. The inside numbers are the same. The outside numbers, that just tells us our answer is also going to be a 2 by 2 matrix. And you have to remember R times C. Rows times column. Every row in the first matrix that I've circled there has to be multiplied by every column in the second matrix. There'll be a lot of these problems on the test. Some are multiple choice, some are not. So I'm going to start by multiplying the first row times the first column. So that's 2 times negative 7. So it's 2 times negative 7. That's this 2 times this negative 7. And then it's that 4 times that negative 7. So we multiply those two together. Just take your time with the arithmetic. So you get negative 42 for the first row times the first column. It's a negative 42. So every row has to be multiplied by every column. So now I'm going to take the first row, multiply it by the second column. Same process. So that's 2 times 17 plus, remember we're adding the products here. It's only, you only subtract when we're finding the determinant of the matrices. So we're adding the products. So 18 goes in the next spot. So now we have to go and repeat the process with the second row. I'm going to multiply the second row times the first column, see what I get there, and so on and so forth. Negative 63 goes in the next spot. There's the work. And there's what we get for the last one. 119 plus a negative 8 gives us 111. So this is our answer. You don't have to have the dimensions as part of your answer. Just the matrix is our answer. Make sure the work is pretty clear on the test so it's easy to check. Number 6, they give you the dimensions for two different matrices. So if we just line them out, if it's matrix A times matrix B, the inside numbers are equal. So since the inside numbers are equal, that means we can multiply. It's the outside numbers that will be the dimensions of the answer. That's what the question is asking. The question is asking, what are the dimensions of the product? The dimensions of the product are 3 by 256. So a big number there, but the same idea as all the other problems. All right, make sure you pause. I'm going to move on down and erase. All right, so I've started this problem already. All I've done here is multiplied everything in the first matrix by 3. And that's how I got 0, negative 63, 18, and negative 24. Second one, you got to be careful on it. It's a 7 with a subtraction sign in front of it. There's different ways to do this, but the easiest way is drop that subtraction down sign below like I did there. And then all I did was actually multiply everything in that matrix by a positive 7. So everything in here got multiplied by a positive 7. So now all that's left is to subtract those two matrices, and that should be pretty easy. All right, so this should be your answer to number 7. I did have a mistake earlier. That should be a negative 105 and not a positive 105. All right, I'm going to move down. All right, so 8, we are adding and multiplying. So you have to follow order of operations. PEMDAS, multiplication comes before addition. So we have to multiply these two matrices, but always check the dimensions first. This first matrix has 2 rows and 1 column, and of course so does the other. So we see right away, if they're both 2 by 1 matrices, they cannot be multiplied because those inside numbers do not match up. They're not equal. So since we cannot multiply those two matrices, there's not really anything we can do in this problem. So we cannot simplify this answer. That'll save you a lot of time if you check the dimensions first. All right, number 9. Again, we are multiplying and then we are subtracting. So let's first multiply. I'm going to take this row right here and multiply it by the first column. So that row has to be multiplied by both columns. Every row has to be multiplied by every column. Of course, the first thing I almost forgot was label the dimensions. This first matrix has 1 row, 3 columns. So 1 row, 3 columns. Second matrix has 3 rows, 2 columns. So those inside numbers are the same. The outside numbers tell us when we multiply those two matrices together, we should get a 1 by 2 matrix. So that's 1 row, 2 columns. Should just get 2 numbers resulting from multiplying those two matrices. So I'm going to go and erase some of this work. So that's the first row times the first column. 2 times 3 is 6. Negative 9 times 2 is negative 18. 10 times 0 is 0. So 6 minus 18, negative 12 is the first number. So now I'm going to take the first row, or the only row, and multiply it by the second column. Every row times every column. So we get negative 82 for the row times the second column. And now all we're going to do is we're going to distribute the 5. We've got to worry about the other side of this problem. I'm going to drop down the subtraction sign. And I'm going to distribute the 5 to that second matrix. So 5 times 8 is 40. 5 times negative 3 is negative 15. So now I've got a 1 by 2, subtracting by another 1 by 2. And now just subtract. All right, so there's your answer for number 9. Number 10, 3 rows, 3 columns. Multiplying a 3 by 3 times a 3 by 2. There will be problems on the test like this, both multiple choice and non-multiple choice. So you have to be able to do these by hand. There's a lot of these. You know, they're long, but it'll be worth it when you get that good test grade. So when we multiply these two together, ultimately our answer should be a 3 row by 2 column matrix. So that tells me I'm going to come up with 6 different numbers for this answer. So the first row times the first column looks like that. And ultimately you get negative 30, so it goes in the first spot. It's really helpful to write the size of your matrix to begin with. That way you know exactly where each number goes. All right, and there's the first row times the second column. You get 20, so it goes in the next slot. Then we're going to scoot down. We're going to multiply. We're going to repeat that process with the second row times the first column. I'm going to speed ahead in this problem a little bit. I encourage you to pause it. If you haven't already tried it on your own, pause it, try it on your own, see what you come up with. All right, we had a little glitch there, but there's the answer to number 10. Check the work. If you got any questions, guys, please let me know and ask. But I'm going to erase, so go ahead and pause if you're still copying and still looking. Number 11, this symbol right here does not mean absolute value. That symbol means the determinant. So it's the same thing as finding the determinant of matrix A, which you can do in the calculator, but this is the non-calculator section. So to find the determinant by hand, it's just A times D. So that's 12 times 0 minus D times C. So there's the setup. I'm going to bring down the subtraction sign. Negative 8 times negative 1 is positive 8. 0 minus 8. So your determinant is negative 8. That's all you had to find in this one. The next questions ask for the determinant and then the inverse. So a little bit more work on the next few problems. So I'm going to work out 12 step by step, and then 13 I'm just going to have the answer. 14, as you recall, you do not have to do number 14. So first find the determinant of 12. So that's just like we did the last problem. We're going to do it by hand. So that's 6 times 1/3 minus 5 times 2. 6 times 1/3 is the same thing as taking 6, multiplying it by the 1, and then dividing by 3. So 6 times 1/3 is just 2 minus 10. So our determinant is -8. I don't feel like spelling that whole word out. But somewhere you need to indicate that that's the determinant, -8. And circle that and let me know that's part of your answer. If you just got all your work kind of scattered throughout, it's not really clear that you understood when you found the determinant. So label that however you see best fit. So now we're going to find the inverse. So if this is matrix A, we need to find A to the -1 power, which means A inverse. So we are going to use that formula, which is 1 over -8. We're going to switch the 1/3 and the 6. They switch spots. The 2 and the 5 don't switch spots, but they do switch signs. And then last but not least, we're going to multiply everything in this matrix by 1 over -8. 1 over -8 times 1/3. To multiply two fractions, you multiply the two tops. So 1 times 1 is 1. -8 times 3 is -24. So that's what you get when you multiply 1/8 times -1/8 times positive 1/3. 1 over -8 times -2 is -2 over -8, which can be reduced. I'll do that in the last step. 1 over -8 times -5 is -5 over -8, which can be simplified a little bit. And then finally, 1 over -8 times 6 is 6 over -8. That would give you most credit, but we want to go ahead and reduce this. So I kind of had to cram the fractions in there, but my fractions are 1 over -24, -2 over -8 reduced to positive 1 over positive 4. -5 divided by -8 is now positive 5 over positive 8, and 6 over -8 is now positive 3 over -4. But pause, I'm going to scroll down next. So 15 is a question either you know or you don't. Those are the three identities. I've shown you the 2x2 and the 3x3 and the 4x4. Or I've shown you the 2x2 and the 3x3. Hadn't shown you the 4x4, but I think you kind of see the pattern that exists there. That's the same thing as multiplying something by 1. So that's 15. That question will probably be on the test, so make sure you know that. Number 16 does not say solve. It says write as a matrix equation. So we did this the other day. The matrix that we would put in for matrix A would be the coefficient. So that is 3, -7, 22, and -1. That's just my coefficients. To get an equation, we also need some variables, the variables that we're trying to solve for x and y. And if we multiplied 3, -7, 22, -1 times whatever x and y are going to be, it would yield 12, 3. That's all they're looking for when they ask for a matrix equation. Don't actually solve it, but you need all three of those matrices to be correct for 16. All right, moving on. So now here proceeds the calculator portion of the test. So you can use calculators here. I'm not going to go through all the work here, so I think you guys have this down. If you've got calculator questions you need to ask, I can't help on test day if you don't know what button to press in the calculator. But we're going to use technology to help us solve for x and to solve for y. Ultimately, you're going to put these matrices in for A. This should be matrix A, 6, 2, 1, -5. And matrix B would be 24, 20. To solve, to get your answer, to solve for both x and for y, you're going to multiply a, the inverse of a, times b in your calculator. Which, speaking of which, you can do this by hand. It would just take a little bit longer. Ultimately, your answer for this problem, let me see, x is equal to 5, y is equal to -3. You could also leave it in matrices form, 5, -3. Both those would work. Or you could even write it as an ordered pair. If you're an overachiever, do all three. All right, go ahead and pause if you're still copying. I'm going to erase. All right, 18A, B, and C. I think you guys have got the hang of this. The same thing as number 17. We're just solving those using matrices. No different, just different numbers. So I'll leave 18A, B, and C for you guys. Just know for C, write your answers as fractions because you will get some messy decimals. So write your answers as fractions. So that just at the very end when you get your answer, you press math enter enter, math enter enter to get your decimals converted to fractions. All right, this is the second time we've seen these symbols. Remember, this does not mean absolute value in matrices world. It means find the determinant. So this is one of the few problems that you cannot do by hand. At least I haven't shown you how to do a problem like this by hand. So this is straight up in the calculator. If you do not know how to do this, you need to ask me how to do this using your technology. Same thing on 20. 19 and 20, I believe, are the only questions that you cannot do by hand. At least I have not shown you. But number 20 is completely in the calculator as well. So you're finding the inverse. So this involves putting this matrix in for A, and then you want to find A inverse. And again, you can just do that in the calculator. All right, last page is the word problems. We are going to do 21, 22, and 23. So you want to start all these problems by identifying what your X and what your Y variables are going to be. So I always tell everybody, look for the question. You know you're going to have two variables. The questions are going to tell you what they are. So that first question says, how many two-point shots did the Lakers make? So since that's the first question, I'm going to make that my X variable. My X variable is going to be 2-point shots made. The second question is how many 3-point shots did the Lakers make? So Y is going to represent the 3-point shots that are made. So that's what you need to do first. Identify what your X and what your Y, what you're actually trying to solve for in this problem. So I'm going to go right here. It says the Lakers scored a total of 80 points in a basketball game. So if they scored 80 points in a basketball game, we need to figure out, okay, to get those 80 points, how many of those points came from 2-pointers and how many of those points came from 3-pointers. So to come up with that, we know that every X is a 2-point shot, and we know that every X is worth 2 points. So 2x is how I'm going to start the first equation, plus 3y. So y is the 3-point shots made. The y's are worth 3 points, and those are going to total up to equal 80 total points in the problem. So you know from these problems you need 2 equations. So to come up with your second equation, you're going to read the next line. The next line said the Lakers made a total of 37 2-point and 3-point baskets. So all together, they made 37 shots. Now, how many of those shots were 2-pointers and how many of those were 3-pointers? We don't know, but we do know that if we took the sum of x and y, the 2-point and 3-point shots, it should equal 37. So that's the setup for this problem. Now use matrices to go ahead and solve for x and solve for y. So make sure you can actually come up with this answer, but I found that they made 31 2-point shots and they made 6 3-point shots. (22) Identify your variables, just like we did in the last problem. Find your question. The question is, how much does each size of chandelier weigh? So when it says each size, that must mean there are 2 different sizes, which is good because we need 2 different variables for this problem. All right, so I found that X is the small chandeliers and Y is the large chandeliers. Those are the 2 different types of chandeliers. So in the first box, he packed 2 small and 5 large. So that's 2x plus 5y. And the total weight is 132 kilograms. And in the second box, he packed 2 small chandeliers and 3 large chandeliers, which had a total weight of 88. There's the setup. Leave the solving for you guys. The work, go ahead and check the work. I will give you the answer here in about 10 seconds. So there's my answer. I got x equals 11. So it's 11 small chandeliers. I got y equals 22. So it means there's 22 large chandeliers. Last but not least, number 23. Guess what? We're going to go to the question to figure out what our variables are going to be. So the question says, how many adult tickets and student tickets were purchased? X is going to be my adult tickets. Y is going to be my student tickets. 2 things they ask about, so those are my 2 variables. So the question, how many adult tickets and student tickets were purchased? Well, we do know that there were 8 tickets total purchased. So that means one of your equations is going to be x plus y equals 8. There's a total of 8 tickets purchased. We don't know how many of those were adult and how many of those were student, but we do know them added together. Their sum gives us 8. We also know that an adult ticket, an X, cost $7.25. A student ticket costs $5.50. So those 2 figures are dollar amounts, so you can probably guess they're going to equal another dollar amount, $52.75. So there's the setup. You should get whole number answers for this problem. All right, so here's your answer. Adults purchased a whopping 5 tickets. The students purchased 3 tickets. So not a popular show. Must have been terrible. But that's your answers for the test review. 24 is just extra credit. If you'd like to attempt that question, feel free. But those 23 questions, that's what your test is going to look like. Study this. If all you did was copy my answers, you're probably going to do horrible. You want to make sure you actually practice these problems on your own. If you would like a blank copy of the test review, let me know. If it's too late to let me know, the test review should be on my Fusion page. If it's not, you can always email me. Good luck. Bring this in on class on Tuesday, and I'll see you then.